Hello and welcome. In this video, we will explore techniques for integration, a fundamental topic in IB mathematics analysis and approaches higher level. Our focus will be on finding particular values of functions, integrating composite functions of the form f of ax plus b, and integrating trigonometric functions using identities. By the end of this session, you will be able to solve a variety of integration problems, including those that require multiple steps and the application of trigonometric identities. Let's begin with our first objective, finding the constant of integration, c. When we integrate a function, we always get a family of functions that differ by a constant. This is why we add plus c. For example, the integral of 2x is x squared plus c. This represents an infinite number of parabolas, each shifted vertically. To find the specific function we're interested in, we need more information. This information is usually given as a particular value of the function, often called an initial condition. Let's look at an example. Suppose we are given the derivative, f prime of x equals x cubed minus 2x squared plus 3, and the condition that f of 0 equals 2. First, we integrate the derivative to find the general form of f of x. We integrate x cubed minus 2x squared plus 3 with respect to x. Using the power rule for integration, we get x to the power of 4 over 4 minus 2 times x cubed over 3 plus 3x, all plus our constant c. Now we use the given condition, f of 0 equals 2, to find the value of c. We substitute x equals 0 into our expression for f of x and set it equal to 2. This simplifies to 0 plus c equals 2, which means c must be 2. Finally, we substitute this value of c back into our general solution to get the particular function. So the specific function is f of x equals x to the power of 4 over 4 minus 2x cubed over 3 plus 3x plus 2. This process allows us to pinpoint one function from the infinite family of possible functions. Let's try another example, this time involving trigonometric functions. Consider the problem of finding f of x given that f prime of x equals 2 sine x minus the square root of x and f of 0 equals 4. As before, we start by integrating the derivative. We need to integrate 2 sine x minus the square root of x. It's helpful to rewrite the square root of x as x to the power of 1/2. The integral of sine is negative cosine x, and the integral of x to the 1/2 is x to the 3/2 divided by 3/2. This gives us negative 2 cosine x minus 2/3 x to the 3/2 plus c. Now we use the condition f of 0 equals 4 to find c. Substituting x equals 0, we get negative 2 cosine of 0 minus 2/3 times g to the 3/2 plus c equals 4. Since cosine of 0 is 1, this simplifies to negative 2 plus c equals 4, which means c is 6. Plugging c back in, we get our final function. The particular function is f of x equals negative 2 cosine x minus 2/3 x to the 3/2 plus 6. This method is consistent for any type of function, as long as you can integrate it and have an initial condition. Now, let's extend this idea to second derivatives. Our next objective is to find a function when we are given its second derivative. If we have the second derivative, f double prime of x, we need to integrate twice to get back to f of x. This means we will have two constants of integration. Let's work through an example. Find f of x, given that f double prime of x equals 12x squared minus 4, f prime of 0 equals negative 1, and f of 1 equals 4. First, we integrate f double prime of x to find f prime of x. The integral of 12x squared minus 4 is 4x cubed minus 4, plus our first constant, which we'll call c. We use the condition f prime of 0 equals negative 1 to find c. Substituting x equals 0, we get 0 minus 0 plus c equals negative 1, so c is negative 1. This gives us the complete expression for the first derivative. So f prime of x is 4x cubed minus 4x minus 1. Now we integrate f prime of x to find f of x. The integral of 4x cubed minus 4x minus 1 is x to the power of 4 minus 2x squared minus x, plus a second constant, which we'll call d. We use the second condition, f of 1 equals 4, to find d. Substituting x equals 1, we get 1 minus 2 minus 1 plus d equals 4. This simplifies to negative 2 plus d equals 4, so d is 6. Finally, we have our particular function. The function is f of x equals x to the power of 4 minus 2x squared minus x plus 6. This two-step integration process is essential for solving problems involving second derivatives. Let's move on to our third objective, integrating composite functions of the form f of x plus b. This is a very common type of integral. The key is to recognize the linear function inside the main function. The general rule is that the integral of f of x plus b is 1 over a times the integral of f of u, where u is x plus b. The 1 over a factor is crucial. Let's see this in action with a power function. Find the integral of 2x plus 3, all to the power of 4. Here, our f function is u to the power of 4, and our x plus b is 2x plus 3. So, a is 2. The integral of u to the 4 is u to the 5 over 5. Applying our rule, we multiply by 1 over a, which is 1 over 2. This gives us 1 over 10 times 2x plus 3 to the power of 5 plus c. Let's try another one, this time with a square root. Find the integral of 1 over the square root of 1 minus 3x. First, rewrite the expression using a negative fractional exponent. This is the integral of 1 minus 3x to the power of negative 1/2. Here a is negative 3. The integral of u to the negative 1/2 is u to the 1/2 divided by 1/2, which is 2 times u to the 1/2. Applying the rule, we multiply by 1 over a, which is 1 over negative 3. This gives us negative 2/3 times the square root of 1 minus 3x plus c. This pattern applies to all standard functions. For example, the integral of e to the x plus b is 1 over a times e to the x plus b. Let's integrate 2e to the 2x minus e to the negative 3x. For the first term, a is 2, so we get 2 times 1/2 e to the 2x. For the second term, a is negative 3, so we get minus 1 over negative 3e to the negative 3x. This simplifies to e to the 2x plus 1/3 e to the negative 3x plus c. Remembering this 1 over a factor is key to successfully integrating composite functions. Our final objective is to integrate trigonometric functions using identities. This is a common technique in HL mathematics. Sometimes, a trigonometric integral isn't in a standard form. We can often use identities to rewrite it into a form we can integrate. A very useful pair of identities are the power-reducing formulas for sine squared and cosine squared. Sine squared theta equals 1/2 minus 1/2 cosine of 2 theta, and cosine squared theta equals 1/2 plus 1/2 cosine of 2 theta. Let's see how to use these. Integrate the quantity 2 minus sine x squared. First, expand the expression. Expanding gives us 4 minus 4 sine x plus sine squared x. Now we can't integrate sine squared x directly. This is where the identity comes in. We replace sine squared x with 1/2 minus 1/2 cosine of 2x. Combine the constant terms. 4 plus 1/2 is 9/2. So we are integrating 9/2 minus 4 sine x minus 1/2 cosine of 2x. Now each term is in a standard form we can integrate. The integral of 9/2 is 9/2 x. The integral of negative 4 sine x is 4 cosine x. And the integral of negative 1/2 cosine of 2x is negative 1/2 times 1/2 sine of 2x. This simplifies to 9/2 x plus 4 cosine x minus 1/4 sine of 2x plus c. This example demonstrates how a simple identity can transform a complex integral into a manageable one. Let's look at another important identity, the double angle formula for sine. We know that sine of 2x equals 2 sine x cosine x. This identity can be used to simplify integrals involving products of sine and cosine. Consider the integral of sine x cosine x. We can rewrite the integrand using the identity. Since sine 2x equals 2 sine x cosine x must be 1/2 sine 2x. Now this is a simple integral of the form sine of x plus b, where a is 2. The integral is 1/2 times negative 1/2 cosine of 2x plus c. This simplifies to negative 1/4 cosine of 2x plus c. This is a much more straightforward calculation than trying to use a substitution method. Finally, let's discuss integrating rational functions. Sometimes, a rational function can be simplified before integration. Consider the integral of 3x minus 1 all over x plus 2. The degree of the numerator is equal to the degree of the denominator. In such cases, We can use algebraic division or a clever manipulation to simplify the expression. We can rewrite the numerator, 3x minus 1, as 3 times the quantity x plus 2 minus 7. This is equivalent to 3x plus 6 minus 7, which is 3x minus 1. Now we can split the fraction. This becomes 3 minus 7 over x plus 2. This form is much easier to integrate. The integral of 3 is 3x. The integral of 7 over x plus 2 is 7 times the natural logarithm of the absolute value of x plus 2. So the final answer is 3x minus 7 ELN of the absolute value of x plus 2 plus c. This technique of simplifying rational functions is a valuable tool in your integration toolkit. Let's recap what we've covered. We started by learning how to find the constant of integration c using initial conditions. We saw that this process can be extended to find a function from its second derivative, requiring 2 integrations and 2 initial conditions. We then explored integrating composite functions of the form f of ax plus b, emphasizing the crucial 1 over a factor. Finally, we learned how to use trigonometric identities, like the power-reducing formulas, to transform integrals into a more manageable form. Mastering these techniques is essential for success in IBAAHL calculus. Now let's test your understanding with some practice questions. Here are 5 practice questions designed to reflect IB-style assessment. Pause the video and try to solve them on your own. The solutions will follow. Question 1. A curve has gradient function d dx equals 3x squared plus 2x and passes through the point 2, 5. Find the equation of the curve. Question 2. Find f of x given that f double prime of x equals cosine x, f prime of pi over 2 equals 0, and f of 0 equals 3. Question 3. Integrate 4 times the square root of 5 minus x with respect to x. Question 4. Show that sine x times the quantity 2 sine x minus 1 can be written as 1 minus cosine 2x minus sine x. Hence, find the integral of sine x times the quantity 2 sine x minus 1 dx. Question 5. Find f of x given that f prime of x equals 2x minus 2 over the quantity 1 minus x, and f of negative 1 equals 3. Welcome back. Let's go through the solutions together. For question 1, we integrate the gradient function to find the equation of the curve. The integral of 3x squared plus 2x is x cubed plus x squared plus c. Using the point on 2, 5, we substitute x equals 2 and y equals 5. This gives us 5 equals 8 plus 4 plus c, so c is negative 7. The equation of the curve is y equals x cubed plus x squared minus 7. Now for question 2, which involves a second derivative. First, integrate f double prime of x to get f prime of x. The integral of cosine x is sine x plus c. Using f prime of pi over 2 equals 0, we find c is negative 1. So f prime of x is sine x minus 1. Next, integrate f prime of x to get f of x. The integral of sine x minus 1 is negative cosine x minus x plus d. Using f of 0 equals 3, we find d is 4. So f of x is negative cosine x minus x plus 4. Question 3 is an integration of a composite function. Rewrite the expression as 4 times the quantity 5 minus x to the power of 1/2. Here a is negative 1. The integral is 4 times 1 over negative 1 times 5 minus x to the 3/2 over 3/2. This simplifies to negative 8/3 times the quantity 5 minus x to the 3/2 plus c. Question 4 requires the use of a trigonometric identity. First, expand the expression to get 2 sine squared x minus sine x. Now, use the identity sine squared x equals 1/2 minus 1/2 cosine 2x. This gives us 2 times the quantity 1/2 minus 1/2 cosine 2x minus sine x. This simplifies to 1 minus cosine 2x minus sine x as required. Now we integrate this simplified expression. The integral is x minus 1/2 sine 2x plus cosine x plus c. Finally, question 5. Question 5 involves a rational function. Integrate f prime of x to find f of k. The integral of 2x is x squared. The integral of negative 2 over 1 minus x is negative 2 times 1 over negative 1 times the natural logarithm of the absolute value of 1 minus x. This simplifies to x squared plus 2 ln of the absolute value of 1 minus x plus c. Using the condition f of -1 equals 3, we substitute x equals -1. This gives us 1 plus 2 ln of 2 plus c equals 3. So c is 2 minus 2 ln of 2. The final function is f of x equals x squared plus 2 ln of the absolute value of 1 minus x plus 2 minus 2 ln of 2. That concludes our session on integration techniques. We have covered finding particular values, integrating composite functions, and using trigonometric identities. Remember, practice is key to mastering these concepts. Continue to work through problems from your textbook and past papers. Thank you for watching.